My name is Brian McCarter, Sarah Knight, John Hayes. We have designed a Workcell to build truing tools. And John, do you want to show them what it does?
Right here is one truing tool that we've already produced. As you can see, it started out as a 3-inch piece of 5/8 inch round stock, and we turned it down on the CNC lathe for the correct taper. We also had it drilled, deburred, and a roll pin pressed through it. Just in case if you guys didn't get what we were talking about in the report for what it actually does, I've got 2 brass mouthpieces for brass instruments for a band. And sometimes, like my 2-bit mouthpiece here, it will be dropped out on the marching field or something. It'll get a big dent in it. You can take this and straighten it back out. It's been designed from another part, which it'll accommodate any brass instrument, which is one plus of it. So,
very good.
If you guys want to take a look at that.
Okay, before we start, we would like to ask you to wear safety glasses, which we've got a couple choices for you.
We've all been there before. John got the cool one.
All right, if you want to step up, we'll go over the...
Sneak over here in the corner. Yeah.
All right, we'll go over we're going to go over the cycle for you. It is on a continuous cycle. It does 2 parts at once. Right now, it's about to drop off an already tapered blank into the drill. We had a problem with drilling because the blank is steel. We've not been able to get enough power to make it through, so we will stop the cell and pull it up. We'll still fire off the drill and show you how it was going to work. After it drops it off, it will pick up another blank and start it in the lathe. And while it is lathing down, the robot will grab the deburring tool and wait for the drilling to finish, and then it will come and demonstrate its deburring abilities, I guess. It will then take the deburring tool back, take the drilled part to the pin press station where a pin will be inserted through the hole. From there, it will be palletized on that far side. Our pallet holds up to 3 finished products. Once the pallet's full, the robot program stops, and it can be emptied by an operator or another robot if there was one. After it palletizes it, it will take the taper part out of the lathe and just keeps going in a cycle.
What's your cycle time?
The cycle time, the lathe itself takes about 10 minutes, and the rest of it is probably about 5 minutes or so, 5 to 7 minutes. Like I said, there's going to be certain times where we're going to have to stop the program because we haven't, completely perfected it. I guess do you guys have anything else? All right, we're going to start it, watch a run through. It's kind of loud because of the vacuum, so if there's any questions, just speak up, and we'll get it going here. We started with a little operator start. Here's one of our molds. The robot didn't sense that it didn't have parts, so it went back and tried again. Make sure it didn't have it.
can only have an input where it says it to where it'll tell it to start, or that when an output when it's done. Our lathe is still running even though it's in hold mode. It's kind of hard to get a sensor on the lathe itself due to the lathe tool itself moving, and since the truck turns.
The robot missed the air chuck actually, which we can go quickly fix, and we'll show you after it does a cycle. But we did hold it, and it'll start the deburring now. Should start deburring.
At that point, it was putting a chamfer on here and getting rid of the burrs.
Here, it would pick it up, and it would clamp it. But like, there's no part in there you can put. John, move the fiber optic out of the way. Are you gonna help the pin press?
The other thing is, pin press, unfortunately, we aren't having it completely work right now. One problem we had is that there wasn't enough force pushing down on it, and also, since we had plexiglass so readily available, we attempted making it out of plexiglass, but it's not really holding off as well as aluminum would. So if we were to do it again, that's what we would use.
fire that manually.
Hurry up and stop
there you
it. Hurry up and stop it.
Go over there, and then I'll put it in free mode. Okay. Alright. Yeah. Here, Case, can I take that? Gotta move it back in again. Keep going. Okay. Alright, start it. The robot is now waiting for the lathe to finish its operation. Right now it's taking its final pass, but of course there's not a part in there right now, but that's what it should be doing.
Was the part that you passed around machined on this way?
Yes, it was.
Glad to see from this group is your PLC program and all your word address programs and everything included in your report. Your descriptive report of the guys, as this final is here that you're done showing us, can you help us?
We need to grade you in certain areas. One of those is safety systems. The other would be software language and technique. So if you could talk a little bit about what you've done there, might help us in our evaluation.
Here you can see some of the software language and techniques. Well, actually, here the tail sock is now retracted, and the robot would be picking up the part out of the lathe.
And that's where it started.
And that would be where it started, waiting for the operator to pull the part out.
If you want to talk about safety, I was gonna reteach the position so you could see the lathe, why it works. It was just the positions were off in a couple spots. You know,
That's an understandable situation.
yeah, not too much to do about it. You know, first.
Would love to see a little bit about how you set up your interface and your diagram.
Yes, I can.
Construction of the work cells.
I can show you those. You want to stop the program for when I start? Okay, for safety real quick, one thing you can obviously see is we had a safety gate across the front and the light curtains. Also, the area that the operator is safe in has been outlined on the floor with safety tape. We have several signs around the system. One right here which says danger, robot in operation. Another one over by the pin press fixture where it says danger, keep hands away due to the high force to press the pin through. Another one where it says danger, eye protection required when working in this area. And also another sign that says danger, hot metal, because as the part is getting turned on the lathe, it does generate quite a bit of heat, and it is very hot. Another part is on our control panel. We have a series of an array of lights, as well as a light stack over to the side. When the CNC lathe was running, the blue light would come on. When the robot goes into emergency mode, the red light will come on. When the robot has power coming to the system, the amber light will come on. When the robot is actually running, the green run light will come on. Over on our control panel, we also have an array of lights which alert the program or alert the operator whether the program is running, the power on, the emergency stop mode, or and also the CNC lathe running. Also, we have a series of lights that tell you when the pins are low and when the round stock are low, as well as empty. We also have a light that alerts you when it's in hold mode, which as you can see it is illuminated right now because it is in fact hold mode. It alerts you when the pallet's full, also when it's deburring, when it's drilling, and when the press is actually in operation. We also have a key switch which controls the overall power for the entire cell. It kills the AC power as well as the DC power, and it kills both sides of both of those powers. We have also a power lockout box where we can actually lock the power out so that nobody can get into the system, or so that they can have the power off while they are wiring. We also have a caution sign on the access area to the back of the lathe. We have, if we want to take a look at the electrical area, we have our electrical board mounted on slide track for easy access, as well as our valve board mounted on slide tracks for easy access. All of our relays are labeled as to their function, and also we have we have the wires color-coded as well as numbered for ease in troubleshooting. We also have the electrical technician's resource book, of which we have the I/O list in, as well as all of the schematics for the actual cell. On the control panel, we have the control panel and all of their functions, as well as a diagram of the control panel, and we also have a listing of where each of the wires go for each of those. On the back of our control panel, as well as on our valve board, we're utilizing 25-pin and 9-pin male-female connectors. We also have those diagrammed, the pins and the colors and where they go. We have a list of the relay board and where each wire for each relay should go, as well as any schematics for individual sensors. For example, the Opto Touch starts, the Turk sensor controller we have for the DC proxes, as well as the DC proxes, the AC proxes that we have, and any safety circuits, the interface for the CNC lathe, the color-coded sheet for that. We have all that documented for the electrician. As well as on the control panel, we have a cover on the bottom, and the bottom is also labeled as to how it is laid out and where the wires need to be attached to. All of the cylinders are labeled, and also all the air tubes going to the cylinders are labeled to their port number, or to their cylinder number, as well as their port side, as well as on the relay, or the solenoids down here, they are also labeled.
noticed with your two-hand start, you did a double contact on that. Is there a reason for that?
Yes, that's so that you can't have the operator reaching out into the area to start it. Because if they were to have their hand on the robot and the robot takes off, that could do some serious damage to the operator.
That's the reason for the two-hand start. Why did you have to touch it twice?
Because you can put something.
Because
you could put a pencil in here and it would trigger it, and you could have your one hand free.
Because I can go like this and try to go like that, but it won't start up unless I do it on both sides. And I can't go because we have an anti-tie down circuit where you have to have it within a half a second. Also, our CNC lathe, it is equipped where if you were to hit the emergency stop button, if we were to hit the emergency stop button, that would kill the power to the lathe itself also, so that if there was a problem with the lathe, you could easily kill the power for that. Also, the key switch kills the power for the lathe.
Good. Excellent job, gentlemen. Yep.